told you we were going to be continuing to talk about limits, and there's a rule about limits that I haven't told you about yet. It's called L'Hôpital's rule. L'Hôpital in French is hospital. I don't know what that has to do with limits, but that's what the rule is called, L'Hôpital. So, what L'Hôpital's rule says is that when you're taking the limit, if you have 0 over 0 when you plug in the number, or if you have infinity over infinity, or any combination of a negative infinity, that what you can do is you can take the derivative of the top, and you can take the derivative of the bottom. And the original problem, its limit will equal the limit of this. So basically, you can plug in the number, see what you get. As long as you get one of these things, then you can take the derivative of top and bottom, and then you can solve. So let's look. The rest of the video pretty much is going to be a lot of examples to show you ways that you can use it. So let's say that you have the limit as x approaches 2 of 3x squared minus 7x plus 2 over x minus 2. Now, because we're approaching x equals 2, this would be a problem maybe where you would normally try to factor or something. With L'Hôpital's rule, you don't have to do all of the rules every time anymore. So if you plug in 2, you end up with 0 over 0. You should always plug it in first. Since I end up with 0 over 0, that says I can use L'Hôpital's rule. So what I do is I say, well, this limit is going to equal the same limit of the derivative of the top, which is 6x minus 7, over the derivative of the bottom, which is 1. Then you can plug in the 2, and you get 5. Alright, on this one, start by plugging in the 3. And this is supposed to be a negative 3, I'm sorry. Plug in a negative 3. On the top you get 0. Square root of 9 minus 5 is 2. 2 minus 2 is 0, so we have 0 over 0. Check, I can use L'Hôpital's rule. The derivative of the top is 1. The derivative of the bottom is 1/2. X squared minus 5 to the negative 1/2 times 2x, derivative 2 is 0. And then I would plug in my number. Negative 3 squared is 9. 9 minus 5 is 4. 4 to the negative 1/2. That means that I take the square root and I put it on the bottom. So that's a 1/2. And then times 2 times negative 3. That's negative 3/2 on the bottom, and so 1 over that would be negative 2/3. It applies to strange things that might look like you can't take the limit of them. Here you would plug in a 1. I want to remind you that ln of 1 is 0. You get 0 over 0. Check. You can use L'Hôpital's rule. The derivative of ln of x is 1 over x. The derivative of x is negative 1. Derivative of the bottom is 4x to the third minus 1. Plug in your 1s. You still have a 0 on the top, but that is okay. So the answer is 0. All of this would normally be on the non-calculator part of the exam, just so you know. If I plug in zeros here, I have 0 squared times sine of 0. Sine of 0 is 0. So that's 0 plus cosine of 0, which is 1 minus 1. So it's 0 on top, 0 on the bottom. Check, I can do it. Got to find the derivative. Now here I'm going to have to do the product rule first. Times the derivative of the second plus the second times the derivative of the first. Derivative of cosine is negative sine. And then over 1. Now plug in your 0. The first part is 0, because that's 0 times 1. Sine of x is 0. That's 0. Sine of x is 0, so it's 0 over 1, so we get 0. The next one is really just to remind you of one of the rules maybe that you haven't thought of in a while. Or several of the rules maybe. Plug in a 0. That'd be 4 to the 0, which is 1. Sine of 0 is 0 minus 1. We have a 0 on the top. Tangent of 0 is 0. Sine of 0 is 0. 0 over 0. We're good. The derivative of 4 to the 2x is natural log of 4 times 4 to the 2x. And then times the derivative of the power, which is 2. Derivative of sine of x is cosine of x. The derivative of tangent is 1 over cosine squared of x. Derivative of sine is cosine. Like I said, that problem is probably just to remind you of how to find all those derivatives. Plug in a 0. 4 to the 0 is 1, so we have 2 ln of 4. Cosine of 0 is 1, so plus 1. 1 over 1 plus 1 is 2, and then we would leave our answer just like that. It is possible that you would have to do L'Hopital's rule more than once. Alright, if I plug in infinity, when you're plugging it in, you're really just thinking like is the number getting bigger or is the number getting smaller? So when I plug in infinity on the top, it's a big number. So the top would be infinity, and on the bottom, e to the infinity is getting bigger. Ln of x or ln of infinity, that's getting bigger. With ln of x, sometimes you're trying to think about what the graph looks like, and it looks sort of like that. So I know that if I plug in infinity, that graph's getting bigger. So that's infinity. Infinity over infinity means I can use L'Hopital's rule, so I'm good there. Now, I end up with 8x minus 5 over 5e to the 5x plus 1 over x. The derivative of ln of x is 1 over whatever you're taking the ln of. Alright, now again thinking about infinity, if I plug in infinity, I get a big number on top. This would be infinity. Okay, this says 1 over the number that's really, really big. Well, that would go towards 0. So this is infinity plus 0. So we still have infinity over infinity. Check. I can still use L'Hopital's rule. I do it again. 8 over 25e to the 5x minus 1 over x squared when I do the derivative of that. Alright, I'm definitely not going to get infinity over infinity this time since I have an 8 on top. That goes towards infinity. That goes towards 0 because that's 1 over a really big number. So that sort of goes away. So I have 8 over a really, really big number. And then what that does is that goes towards 0. That leads you to a rule. Anytime you have a number over infinity, basically what's happening is you end up with 0. So if you just sort of need to know that, or think about it, if a number over a really big number is a really small fraction, and so that's why that's going towards 0. Now, on a problem like this, I can already look at this and I can tell that the limit of this is going to be 2 because I can use your asymptote rules. If you would prefer not to use asymptote rules, you can do L'Hopital's rule. You end up with infinity over infinity. Take the derivative, you still get 2. Just wanted to remind you about that one. Now, sometimes with L'Hopital's rule, it's not giving to you directly. There's more things that you might have to do to get it in the form so that you could use L'Hopital's rule. For example, so let's say I have this problem here. If I plug in pi over 2 on each of them, I end up with infinity minus infinity, because that would be 1 over cosine of pi over 2 is 0. 1 over 0, that's another rule I didn't show you yet, but 1 or a number over 0, that means the bottom's getting really, really small. This is going towards infinity. So we have infinity on that first one, minus sine of pi over 2 is 1, cosine is 0, so that again, that's 1 over 0, so that's another infinity. So, this isn't in the correct form yet, but on this particular problem, I could combine, get a common denominator. And now if I plug in pi over 2 on the bottom, I get 0. Sine of pi over 2 is 1, 1 minus 1 is 0, so now I have 0 over 0. Check. I can now use L'Hopital's rule. The derivative of 1 minus sine x is negative cosine x. Derivative of cosine is negative sine. And plug in pi over 2, you get 0 over negative 1, so you get 0. So sometimes you might have to get a common denominator before you can solve it. Another kind of problem is when things are multiplied, you might have to change something around. This says 0 from the right, but if you just do the problem as if it's just a plain 0, then that's going to be the answer. So don't really worry about the 0 from the right. I want to remind you real quick what ln of x looks like. That's ln of x. So the limit of ln of x as x approaches 0 from the right is negative infinity. So if I plug in 0 here, I get 0 times negative infinity. That's another sort of thing you need to know. Either need to know the graph of ln of x like that and look at it to find that limit, or just know the limit of ln of 0 is negative infinity. So we have 0 times negative infinity. So what you do is you rewrite it to make it a fraction. So you leave the ln of x and you move the x squared to the bottom, but when you move it, what that does is that creates a fraction. So you rewrite it as 1 over x squared. And what that does, on the top, that's a negative infinity when you plug in 0. On the bottom, that's 1 over 0. That's getting bigger. So the bottom is infinity, check, and I can now use L'Hopital's rule. The derivative of ln of x is 1 over x. The derivative of 1 over x squared, that's like x to the negative 2, so this would be negative 2x to the negative 3. A lot of times with these, I like to leave them as fractions because it's easier to find the limit when you plug in 0. So if I plug in 0, I'm going to get still like infinity over infinity, but this particular problem, if you keep just finding derivatives, it's going to continue coming out to where you've got these fractions. You can actually simplify this, make it x to the third over negative 2. If it can be simplified, it makes it easier. So you get x squared over negative 2. And now when you plug in 0, you get 0. And you shouldn't use L'Hopital's rule a second time on that one. Even though it looked like you could simplify it. And so you should do that. A lot of these is a lot of manipulation. And it will come with just practice. If you plug infinity in here, that would be infinity times 1 over x, or 1 over infinity 0, so then sine of 0 would be 0, so this is infinity times 0. Infinity times 0 does not equal 0, unfortunately. Sometimes it might, and sometimes it doesn't. So you've got to work on that a little bit. What we're going to do is kind of like what you did on the last problem, how we took that x at the bottom and made it 1 over x. Now, those 1 over x's don't cancel because the one on top is combined with the sign, and so you just have to leave it like that. If you plug in infinity, 1 over infinity is 0, sine of 0 is 0. 1 over infinity is 0, so that's a 0 on the bottom. If you check, you can use L'Hopital's rule. The derivative of the top would be cosine of 1 over x times the derivative of 1 over x, which is, that's x to the negative 1, so negative x to the negative 2. And on the bottom, it's a negative x to the negative 2. They cancel. You end up with cosine of 1 over x. Plug in infinity. That's cosine of 1 over infinity, or cosine of 0, and you get 1. There's some more types of problems that we'll be doing with this, but that's enough for now. You have a shorter video today. There are 3 try problems. The limit as x approaches 9 of x plus 7 minus 4 over x plus 9. Sorry, that's x minus 9. That looks like an old conjugate problem, but you can use L'Hopital's rule on it. This one looks like one of those old denominator problems that we did. But again, I think you can use L'Hopital's rule on it. And then the last one, you've not really done one necessarily like that, but what you do on that one, I think you have to do it twice or 3 times.